So welcome to CS892. What I'll do here is kind of give you an overview of what the course is about, kind of the philosophy of the course. I'll outline the topics we'll be covering, talk about the way the lecture material will be structured, discuss the programming assignments and quizzes. I'll give you a little bit of an overview on how to set up Java and Android interactive development environment on Android Studio, and then we'll talk about ways you can access the source code if you're interested in learning more about how some of the infrastructure stuff works. Let's start by discussing kind of the course philosophy. So it's always been my belief that the best way to learn about something is to do it and not just sort of sit and think about it. So we're going to be doing lots of hands-on experimenting and playing around with the different techniques and object-oriented design and programming and functional programming language features and libraries and frameworks and so on. So you'll really get a chance to apply all these things in practice. And the goal, of course, is to build software that works. That's always great, but not just works, but works well and is easy to write, easy to understand, easy to maintain, and of course is also going to be efficient in terms of time and space complexity, the kinds of things that you probably learned about in other courses like 201 or maybe 251. And as I mentioned before, we'll be focusing both on object-oriented design approaches as well as more recent functional approaches. And you'll see in a second how that all comes together in something called Java 8. So there'll be lots of hands-on stuff. We'll probably have a number of programming assignments. You'll learn about them very shortly. So let's talk a little bit about what we'll be covering in the course. So we'll be covering basic and advanced Java concurrency mechanisms. As you'll see, concurrency really is about allowing computations to run simultaneously, which works great nowadays because almost everybody has multi-core hardware. And we'll talk a lot about that here in just a minute. And we'll be focusing on Java, and we'll also be focusing on this Java 8 stuff. Java 8 has lots of really interesting new features relative to Java 7 and earlier versions. Things like lambda expressions, method references, function interfaces, streams, completable futures, and so on and so forth. So you'll get a real great overview of how all those things are going to work. We'll also be spending some time talking about some of the communication mechanisms that are available in Android. I should also have mentioned that all the Java programming we'll be doing will be done in the context of Android. So you'll get a chance to learn all the Java features using Android as the platform for doing development. And that's pretty cool because it supports pretty much most of the latest and greatest Java 8 features. So you'll be able to learn almost everything that's cutting edge, but apply it in the context of these wonderful mobile handheld devices. And so we'll also be talking about inter-process communication, how you talk between processes on an Android device, and that'll figure in prominently in later parts of the course. We also will probably talk about how you communicate from your mobile device, from your handheld unit or your iPad or your Android tablet to various web services that are running out there in the internet. And you'll get a chance to learn how to access them and also how to store the data that comes back from the web services in something called a content provider, which is basically a way to structure storage on an Android device. And of course, kind of leveraging off of other courses that we teach here, like CS892, we'll also be talking about various patterns and frameworks as they relate to concurrency and network programming. So if you took 251 with me or you took 251 with Graham Hemingway, you undoubtedly learned about some patterns, and we'll be kind of building on that. We'll show lots of those patterns, but we'll also show you some new ones having to do with concurrency. There's a couple of assumptions. We assume that you either know or can very quickly learn Java. Hopefully everybody knows Java. We also assume that you can very quickly learn Android. I'll be covering some of that, and you'll be getting some skeletons that'll help you with the project way of arranging things in your IDE, but you'll have to be able to pick up kind of the nuts and bolts of Android programming pretty quickly, and also learning to use Git, which is a source code management system. If you need some refreshers on these things, I recommend you take a look at our specializations that are freely available on the Coursera platform. There are 3 of them there now. The first one gives a Java for Android programming background, so if you need some refresher on Java for whatever reason, you can learn that. The second course talks about activities, and the third, and broadcast receivers, and then the third one talks about services and content providers. that stuff is there if you need it. Philip.
Said I needed it.
No, you don't.
There's no like
All right, send me email. There's no reason you should have to pay. You definitely don't have to pay. You should be able to just sign up for it, and you'll be able to access everything except for the quizzes. But who cares? So it shouldn't be a problem. So yeah, that stuff should all be there. I know that there are lots and lots of people who are not paying for the course because we have like 25,000 people who are in the course and maybe, I don't know, 200 have paid. So it's not a problem. If you have any problems with that, though, let me know. Okay, so here's the way the course is roughly broken up. The first part of the course is going to be focusing primarily on Java threading, and we'll talk about Java threads and runnables. That'll be your first assignment, and it's a pretty simple assignment, which is why it's due pretty quickly. We'll also be talking about, over time, we'll be talking about some other more advanced features of Java concurrency, things like the executor framework, which makes it easy to run pools of threads. We'll also be talking about some of the Java 8 concurrency mechanisms that are available, things like streams and parallel streams and completable futures. We'll also talk about, by the way, we'll also talk about some of the Android features in this space as well. Android provides some additional capabilities that are thread-oriented, like async tasks and the Hammer framework, which you'll become familiar with. We'll also spend some time talking about Java synchronization and Java synchronizers. These are basically ways of coordinating threads so they don't stomp all over each other. And we'll talk about things like built-in monitor objects, which come baked into Java, the programming language, as well as a whole pile of different synchronizer classes that are part of the Java util concurrent package. We'll spend some time talking about the communication that you can do between processes on an Android device or between an Android device and a web server. And this involves things like Android-bound services and AIDL, as well as content providers. We'll talk more about that. And as I mentioned before, there'll be patterns covered throughout. And we'll be bouncing around a bit between the various topics. So we'll roughly follow this breakdown, but sometimes we may have to jump around because we'll, for example, we'll introduce some topics later that'll cause us to revisit some new or newer synchronizers that you have to do in order to do the assignments. There'll be, as I said, a bunch of different modules. Each module has lessons. Each lesson is composed of parts. Each part is a single lecture. And as you can tell by the funny headgear I've got on my head, at least for this lesson, we're recording everything, and they'll be available in MP4 format. And the PDF versions of all the slides will be available here at this link. If you take a look at this link right now, let's go ahead and drop out of this for a second. Go over here. It's kind of got, right now it's kind of got the bare bones part of this. So it says where the class is. Office hours, we'll have a couple more TAs here put their office hours up in a second, or in the next day once they figure out their schedule. It has the final exam, which is 2 to 5 p.m. on Thursday, May 4th. It's got some placeholders for other stuff, right? So all the programming assignments will be available here. And you can see assignment A is already there. I'd strongly recommend that before next class, you go and download this assignment. And if you take a look at the index.html file with your local browser, once you download it, you can see what the assignment's about. And it's got all the skeleton files and the pieces for this. And this should be able to load right out of the box in Android Studio. So take a look at that. I'll be talking about that next class. So that's where the assignments will be. And then, as I said here, I'm going to put all my videos up on a YouTube playlist, which you can either get them that way, or you can go here, and every week I'll put up the slides and a link to the video, as well as a link to the PDF versions of the slides. So you can always get access to the material. And people find that really useful to study for the quiz that we have every couple weeks, which I'll talk about in a second. Okay, so this is kind of your one-stop shopping portal to get everything about the course, and then it gives links off to other places that store other information. All right. Each of the lectures has these segments, and then we'll have, at the end of each part, there'll be a little discussion period that will go interactively. And that's why I was getting people to kind of sit close together, because what we're going to do is I'll put questions up on the board, and then you guys can work in small groups to kind of discuss what you think that your answers to the questions are, and then we will discuss them. And you'll see there's a variety of reasons for this. It's good to kind of practice for the quiz, because these kind of questions are the kind of questions that show up on quizzes, as well as to get everybody involved and not just be passive and get you involved in the course. Speaking of quizzes, there'll be quiz every other week on the material that we covered in the lectures. The quizzes and the final exam are closed book, which is sort of a metaphor for you're not supposed to use any notes. They're also closed laptop, closed smartphone, closed tablet, closed smartwatch. You can't use any other resources except your brain and your memory to do those. The first quiz will be next Wednesday, a week from Wednesday, and that'll cover what we've covered between now and then. Remember, Monday is a holiday, by the way. I will hand back, we'll try to do our best to get the quizzes graded and back to you by the next class, and I will hand them back. So one of the nice things about having a little bit smaller class is I can actually hand everything back and I get to know people's names, which is way more fun than teaching classes with 90 people in them. And I recommend strongly that you study for the quizzes by watching the screencasts and looking at the slides. People typically really like that because it helps them kind of hone in on what they need to learn. And if you've taken other courses I've taught, you'll know the drill. There'll be a final that's, at least in theory, cumulative. It usually typically covers the more recent stuff, and that occurs at the end of the course. And our final will be 2 to 5 p.m. on Thursday, May 4th, here in this room. Remember, the engineering finals start at 2 rather than 3, and I don't anticipate it'll take 3 hours by any means. It's usually 3 or 4 pages long. It's not very long. And if you forget when the final is, you can either go to the web page or look it up online. This class has got a kind of a funny scheduling time, but it's using the 9 to 10 Monday, Wednesday time slot as the time. So that's how you can look it up. All right, let's talk about the assignments and the assessments. So everything you write here will be written using Java 8 in Android Studio. You can use whatever IDE you want to build your code. However, when you do your final submission, it has to run with Android Studio 2.2.3 and Android 7, which is API version 24. Probably not a big deal if you use a later version of Android Studio or even an earlier version. It's also probably not a huge deal if you use a later version of Android, but just to keep everybody from going insane, as long as your stuff works with that, then you should be fine. By the way, if you are learning Android, I strongly recommend you take a look at this book. It's available on the website. A link to it is under the textbooks link, and it's called The Busy Coder's Guide to Android Development. And it's a fantastic resource. You can get an electronic copy in PDF form, and I strongly recommend you use that as the book if you need additional information beyond what we cover. You'll need to install the Java 8 runtime environment, which you can get from here. Well, this should probably say CS2 or CS892, but it doesn't matter. It's the same information. So this will tell you how to install Java 8. Make sure you install Java 8. If you don't install Java 8, then the more advanced features we talked about won't work very well. And you have to use Android Studio. Android Studio is something you can also download if you haven't already got it. And it gives you all kinds of great things for interactive development. There's a wizard for making apps. There's a visual editor for making GUIs. You won't have to do a whole lot of that because I'll give you that part of the assignment. You can write your XML descriptors in a visual way. It's very visual. There's a debugger, there's an emulator, and so on. You'll probably have to use the emulator for this class unless you've got a really, really, really recent Android phone that's running Android version 7, which is probably not too likely, but if you have one, that's great because it'll be way faster. I strongly recommend a few things I'll talk about later about how you install Android and the Android emulator to make it run a lot faster. Use version 7. This is the one that's got the support for Java 8 in it. It's the Nougat version, which you can read about here. All the source code is available here at GitHub. We just took a quick tour through that just a minute ago. Start with assignment 1A. You'll see why there's 1A, because we're going to have 1B, 1C by the time you're done, and I'll talk about how that gets evaluated in just a second. You'll need to learn how to use Git and GitLab. It's not too hard, but there's instructions on the website that explain how to do it. Make sure you get that up and running. If you're struggling with getting that working, you can always download the material in a zip file. I don't recommend you do that because you're going to need to figure it out how to do it in order to submit your assignment. But if you just want to get up and running and start looking at things and you don't have time to learn Git in the next couple days, that's a good way to go. But make sure you get Git working soon because we're going to be using Git to allow us to look at your code without having to have you email it or something like that. The assignments are pretty stable at this point. I've worked on them quite a bit, and so they shouldn't require much updates, but sometimes there'll be a bug or sometimes things change, and so you may have to occasionally update your repository. We hopefully won't have to do that very much, but be prepared for that. That's all part of being a developer, is learning how to deal with change. The assignments we're going to give you will give you a lot of experience programming Java 8 and Android, concurrency and communication, and again, you can get the assignments here. Here are some of the things we're going to be doing. All the assignments, at least all the assignments thus far, have a common user interface. And it's kind of a whimsical example, but it's a really cool way to see how concurrency works, literally see it. And it's something that we call the Palantir Manager app. So anybody here who knows Lord of the Rings and Tolkien and so on, you'll understand the references. And basically it has a display where you have a certain number of beings that are trying to gaze into a smaller number of Palantiri, which are these mystical seeing stones, if you know the book or the movies. And it's a great example of concurrent resource management because we have a smaller number of things that are the resources and a larger number of concurrent activities that want to get access to them, and they have to coordinate. And so we'll look at about 8 different ways of doing that using all kinds of different concurrency and synchronization mechanisms that I have listed up here. And the cool part is that the UI stays pretty much the same, but we keep changing the way it works under the hood. So you'll also get a real good sense of how it works, because if your program doesn't work, you'll see it literally not working, which is kind of fun. We might tweak a few things here or there, but this is probably more or less what we're going to cover. And I've got a whole pile of new things that I'm introducing this semester that we haven't done before. We're going to assess your results in a couple of different ways. Most important thing is make sure you submit your stuff on time. If you don't submit it on time, you don't get graded or you don't get it reviewed, which is bad. All that kind of stuff is covered in the FAQ, by the way. Here's the way the process works. If you've taken courses from me before, it's roughly the same thing as we've done before, more or less. It's a little different from other things you may have done in other courses, probably. So when your assignment is due, and your first assignment is due a week from Wednesday, then you submit your initial solution, and then I review it, and I send you comments, or I don't send it to you, I make comments in the Git repository that you committed your code in. And then I go ahead and send everybody back their comments, or say, go look at your repository. You pull the results, and then you get a few days to revise your program, and then you resubmit your program. In other words, you go ahead and push it back to Git in your private Git repository, make sure it's private. And then the TAs and the graders will actually grade it, where you get your final grade. So the idea here is that you get feedback and you get a chance to make things better. And if you are diligent and pay attention, works great because you get a lot of feedback. But you have responsibility, and the most important responsibility you have is that your initial submission has got to compile and be largely complete, or we don't review it. So don't think, oh, this is great, I don't have to do anything. I can write really crappy code, and then the teacher will tell me everything that's broken. That's not how it works. If you put effort into it, you get feedback. If you do little or nothing and it doesn't compile, then oh well, you're on your own. So it's really up to you to be involved in that. But a great thing is you get feedback and review on your solutions. And then what we do after I review everybody's code, I then come up with a list of frequently made mistakes, and we talk about that in class. We talk through what people are struggling with and having problems with. So it's a great way to learn how it all works. Something else I really want to emphasize here, it's imperative that your work be your own, and that's true for the assignments, that's true for the quizzes, that's true for the final exam. And I mention this because periodically, I'd say at least once a year, someone doesn't do this, and then we have honor council, and it's a big mess, and people fail the class, or they have all kinds of other penalties extracted against them, and let's not do that. It's really time-consuming and embarrassing for everybody involved. So make sure that the work you do here is your own. And I review everybody's code, so it's pretty easy to spot when people are plagiarizing. Here's some of the assessment criteria. Obviously, your program has to work. 40% of the grade is does it work? And we have automated regression tests that can help you see whether it's working or not pretty well. Remember, testing doesn't reveal all the problems, but it reveals many problems. So that'll help you get part of the way there. And then there's also other things in terms of how do you structure your code and how do you comment your code and are you using insightful techniques and so on and so forth. So take a look at that. That's all up on the web as well. Here's the relative weighting of the course. Quizzes are 40%. We'll probably have about 6, maybe 7 quizzes, depends how it goes. Programming assignments are 40%. We'll probably have 4 graded assignments. Some assignments will have multiple parts where we'll give you the final grade when we get to the end, and I'll give you feedback along the way. There's final exam, which is 10%. And then the other 10% is participation. And this is really, really, really important. And if you learn nothing else in class today, take this to heart. So participation is 10%. That means if you do not participate at all, it doesn't really matter how well else you do, you will not get an A, right? So if you don't participate at all, then it's very hard to get an A. It's possible, but it's very hard. So participation really means 2 things. It means first showing up for class, and it's a small class, and so it's easy to tell who's here and who's not here. And number 2, it means being involved, and you'll see what being involved means. And we're going to actually bake into the course time to be involved, and that's something that I haven't done as much in the past, but I'm going to be really trying to do it here. So being involved means asking questions, participating in the class discussion period, not just sitting there like a bump on a log, passively letting knowledge wash over you, right? It's got to be a 2-way thing. Really, really, really important. I want to make sure nobody is under any impression that not participating is okay, right? You've got to be involved. And it's important because one of the skills we want everybody at Vanderbilt to come away with is to be engaged, I guess is the best way to put it. So this is something that's crucial to be successful in almost any career, is to be inquisitive, to be participating, to be active and engaged. So make sure you're aware of that. And there'll be lots of opportunities to get involved. A couple things here real quick. Setting up Android and Java in Android Studio. So you can go here to this link and you can download Android Studio. There's a bunch of initialization steps. You have to install the Java Standard Edition for Java JDK and JRE 8. So you can grab that from this link here. You can download and install Android Studio. At this point, these are pretty easy things to do mercifully. It used to be complicated and tricky, but now it's pretty much just download Android, download Java, away you go. Make sure when you configure things, set the NuGet version, which is API 24. You're welcome to have other versions, as I said before. If you have other work you do for Android in projects or consulting or part-time jobs, whatever, you're welcome to have other things installed, but just make sure your stuff works with that version because it makes grading a heck of a lot easier. Create an emulator for Android API version 24. You can take a look and see how to do that. It's not too hard. And if you've got an Intel machine, either a Mac or a Windows machine, I strongly, strongly, strongly recommend that you set up the Haxum environment, which will accelerate the performance of your emulator to make it almost usable. It's a little bit slow, sadly, but with the Haxum accelerator, it's way faster. So please try to do that. That'll make your life so much better when it comes to debugging these things. Okay, how do you get access to the source code? So sometimes we will actually be looking at source code. We'll take a look at some of the Android source code. We'll take a look at some of the Java source code. If you want to browse Android source code, you can go to this link and you can browse specific parts. You can also download the Android source code, which I find invaluable to learn how things work under the hood. It's really cool to look at. You can also get the Java 8 source code. You can either browse it or you can download the Java 8 source code. I also have the Java 8 source code. Really, really, really cool to learn how this stuff works under the hood. We'll talk about some of the stuff in the class, but if you're curious, you can find out more things by looking at that. All right, so to summarize things, as with most things in life, you get out of it what you put into it. Be prepared to work hard. There'll be certain points where we have a lot of programming, and I'll try to space it out so you're doing little chunks at a time so you don't have one project that's due at the end of 4 weeks that you procrastinate to the last night, and then it's huge. We'll break it up into smaller pieces with parts so that you get involved and you have incremental deliverables. Do not miss the deadlines. Bad news. Zero tolerance for missing deadlines. If you miss deadlines, you just don't get feedback or you don't get score. Participate in the discussions in class and on Piazza. I set up a Piazza site so we can have class discussions. We'll talk about that in a second. That's a great way to leverage the TAs and me and everybody else, because many people will have a question. If you have a question, many people have that question, so this way you can all benefit from the answer. Another really important point. So there'll be points in class where you can have your laptops open, but not during the lecture and discussion. Well, sometimes during the discussion phase, but not during the lecture phase. And I'm really a stickler on this. And the reason is because I find that a lot of people get distracted and they don't listen in class, and then they come to office hours and they don't know what the hell's going on. And so that's a bad thing for everybody involved. So I know it's hard. We're all, a bit ADD these days with all these distractions, but do not violate this rule. Every class, and this goes for laptops and iPhones and Android phones and tablets and everything else, every class there'll be somebody who thinks, oh, I'm going to be clever. I'm going to sit here and pretend I'm meditating with my phone. And I always see it, and then they lose points. And they wonder, why did I do so bad? Well, because you didn't pay attention. So this is your one warning on this. I'm not going to make a big deal about it publicly, but if you persist in that, you're just losing participation points, and that isn't good. Avail yourself of the resources that we've got at your disposal, the online forums, the office hours, the textbooks, the video lectures that we record, the slides with all the links in them, and so on. Please resist the urge to email me unless it's a confidential thing, like you feel like you got a bad grade on something and you want to talk about it, which is always fine, or if you want to schedule a meeting. My office hours are going to be in the morning here before class, and I'm happy to meet other times. My experience has been in other courses that if I schedule a lot of office hours, nobody ever shows up. So if you want to meet, just send me an email. We'll get together. Not a problem. I'm almost always here at 8 because I get here early to get a parking spot. So this, before class is a perfect time if you can stomach getting up that early. And another thing to point out, I think it's pretty obvious that learning the stuff we're going to cover here is really hot. And Vanderbilt CS students are in huge demand, and the kind of things we're going to be covering will make you even more in demand, which is really exciting. All right, and the last thing, if for some reason there is an emergency, then know the evacuation plan, which I assume means go out that door and run up the stairs and go out of the building. Back in Featheringill and Stevenson Center, they used to actually have evacuation plans, but I haven't seen one for this building. It's too new, but it's kind of obvious, get out of the building. By the way, this is an awesome building. I don't know if you guys have had many classes here yet. I taught the very first class when it opened last semester, and I'm just continually blown away by what a great building it is.